Now we're going to switch gears and talk about average cost. I thought I'd put a break just because marginal analysis, approximating actual for the next unit is probably enough for a video. But the next part says, let's use the same exact function. So we're still talking about the C of X is 200,000 plus 265X. And instead of looking at actual versus marginal cost, let's look at the average cost for each recliner. So talking about in this lesson, average cost formula. So average cost is always labeled C bar of X. Average in math is just denoted with a bar. And average is found by taking the total and dividing it by the number of numbers. Probably something you've known for a long time, how to find an average, your quiz average, add them all up, divide by the number of numbers. This is the total cost divided by X, the number of numbers, is going to give you the average cost. So doing that to this equation here, at the top of the page we have 200,000, and that's going to get divided by X, plus 265X, and that's going to get divided by X. So if we were taking the derivative, I'd want to write that as 200,000 x to the negative 1. I'm looking at this next step. It's not asking for marginal average cost, so I'm not going to rewrite it nicer for the derivative. I'm not going to bring up that negative exponent, but I will probably just cancel out those x's in that second term because I do think that makes it a little bit nicer. If you're just asked for marginal cost, average cost, you do not have to simplify. It's when you have marginal average cost that you want to bring up that negative exponent. But all I did here is I said, well, 265x divided by x, those just cancel out. So it's really just plus 265 at the end. So the next part says, what happens to the average cost function when x is very high? So I didn't technically have to simplify my average cost, but because I'm looking at the next step and I'm doing something with it, I did just cancel out those x's. I want to figure out what's happening when x is very high. We've done this before. We've let x get very high. That means we've let x go to what number? What's the highest number you can think of? It's infinity. So when you see when x is very high in the homework, or there's one like this on the practice test, you're just going to take the limit as x goes to infinity, which is kind of nice because those were easier limits, I think. You're thinking bottom heavy. That's the best. Bottom heavy is going to go to 0. You're thinking equal, which is the next best. You'd find the ratio of leading coefficients. The number is next to the highest power. Or if it's top heavy, that's the worst case scenario. But the answer is infinity or negative infinity. You just divide by the highest power of x in the denominator. So you can definitely go back and flip through your notes and look at these limits at infinity from exam 1 because we're going to use them again in exam 2. So when x is going to infinity, we're thinking bottom heavy, equal, or top heavy. So doing that with this function, we're going to take the limit as x goes to positive infinity because we want to figure out what's happening when x is very high. What happens when production goes up super high? We saw what happened when we increased from 200 to 400, but in general, what's happening to the average cost if x is getting as high as possible? So we're going to take it of the average cost function, which we just found above. It was 200,000 over x plus 265. So we have two pieces here to think about for our limit. Let's look at this first piece, 200,000 over x. Is that top heavy, bottom heavy, or equal? Well, there's no x in the numerator. There's only an x in the denominator. So this one's bottom heavy. It's x to the 0 in the top. It's not written though. And then it's x to the 1 in the bottom. In other words, the bottom is the only one that has an x. So it's definitely bottom heavy, which is just going to go to 0. Bottom heavy is the best. It just goes right to 0. Even if you have 200,000, if you divide it by way too many things, you end up with nothing to give. And then our second term, as x goes to infinity, 265 is going to stay 265. There's no x there. So no matter what x you plug in, it's just 265. So we end up with 0 for the first term as x goes to infinity because it's bottom heavy, plus 265. So we get $265. What does this mean? This is dollars, so $265 means as production of recliners, gets high, so maybe not at 2 recliners, but at 200, as production of recliners gets high, the average cost of each recliner is how much money? Is $265, which just backs up what we found in part A and B. That as production gets pretty high, the average cost is $265. It matches what we've already found in the first couple parts.